Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 3, Lesson 13. Let's get started. Okay, Exercise 1. Scientists are studying temperatures and weather patterns in the Northern Hemisphere. They recorded temperatures in degrees Celsius in the table below as reported in emails from various participants. Represent each reported temperature using a rational number. Order the rational numbers from least to greatest and explain why the rational numbers that you chose appropriately represent the given temperatures. Well, we can do this by taking what we know about positives and negatives, and since this table is all about temperature, we're going to see above and below. Below means negative, so 8 below 0 would be a negative 8. 12 would be a positive 12. Negative 4, easy. Then we have 13 below would be a negative 13, and then a 0. 2 above is a positive 2, 6 below is a negative 6, and finally a negative 5. So there are all of our temperatures, and now I just need to list them in order from least to greatest. So let's do that. My smallest number is the one that's the most negative. That's a negative 13. So I'm going to have negative 13 is less than. My next smallest number is negative 8, which is less than negative 6, which is less than negative 5, which is less than negative 4, which is less than, well, that's all of the negatives, so then 0. And then my smallest positive number is 2, and that is smaller than 12. So there it is from least to greatest. All right, number 2, Jamie's bank account statement shows the transactions below. Represent each transaction as a rational number describing how it changes Jamie's account balance. Then order the rational numbers from greatest to least. Okay, this is where this is what I've been warning you about. Sometimes it switches to greatest to least, so be careful. And so I'm going to remember that. Explain why the rational numbers you chose appropriately reflect the given transactions. So we have debits and credits and charges and withdrawals, and we need to know what those words mean. A debit of 1220 is going to be a negative, so that's negative 12.20. A credit is a positive, so 4.0, that's not a 0, 08. And then a charge would be a negative, that's a negative 1.50. My point there. When you withdraw money, you take it out, so that's a negative 20.00. Deposit is when you put money into your account, that's a positive 5.50. Get in there, point. And then a debit is when you take money away, that's a debit is going to be a negative, so this is a negative 3.95. And then, wow, that's not a decimal. There we go. And then a charge, also a negative, so negative 3.00. And then I have to go greatest to least. So greatest to least, I need my biggest number, which is going to be positive, obviously. So looks like 5.50. So I'm going to go 5.50 is greater than. My next positive number is 4.08. I did it again. Why? 4.08. There we go. And that's all of the positives. So the next biggest number is the one closest to 0, which would be my negative 1.5. So that's a little bit bigger than negative 1.50. And then the next negative I would run into is a negative 3. So that's greater than negative 3.00. And if you're not sure, put these on a number line. Then the next would be a negative 3.95, and that's a little bit bigger than negative 12.20. So negative 12.20, and that's bigger than negative 20. All right, and there they are, in order from greatest to least. Be careful on the test. You'll see this happen. Don't get in the habit of just least to greatest, because they'll switch it up on you. Number 3, during the summer, Madison monitors the water level in her parents' swimming pool to make sure it is not too far above or below normal. The table below shows the numbers she recorded in July and August to represent how the water levels compare to normal. Order the rational numbers from least to greatest this time. So least to greatest. Explain why the rational numbers you chose appropriately reflect the given water levels. Well, we just have above and below. Above is going to be positive, below is going to be negative. So above, 1/2 above, that's a 1/2. 1/4 inch above, that's a positive 1/4. 1/2 inch below is a negative 1/2. 1/8 inch above is a positive 1/8. 1 1/4 inches below is a negative 1 1/4. 3/8 of an inch below is a negative 3/8. And then 3/4 of an inch below would be a negative 3/4. All right, and then we need least to greatest. So let's see, my smallest number is going to be the one that's the most negative. So that's negative 1 1/4. Negative 1 1/4 is less than, and let's see, I've got some fractions here in my negatives. I have this negative 1/2, I have a negative 3/8, and I have a negative 3/4. I would like to make these all the same denominator so I can compare them easily. So I'm going to use this space down here. I'm going to make this negative 1/2 into 8ths. So that means I have to multiply by 4, multiply the top by 4, and I get a negative 4/8. So this negative 1/2 is the same as negative 4/8. And then I already have the negative 3/8 in 8ths. So let's change this negative 3/4 into something over 8. That means I'd have to multiply by 2, multiply by 2. Let me try that again. Multiply, oops. I want it to be 8ths. I'm going to multiply by 2. Multiply the top by 2. That gives me 6/8 negative. So this is a negative 6/8. And now I can tell which one is the next smallest, the one that's the most number of 8ths. So this is negative 3/4 is my next smallest. And then followed by negative 4/8, which was my negative 1/2. And that is a little bit smaller than negative 3/8. Okay, and so those are gone. Now I'm into my positive numbers. And I have, again, 1/2, 1/4, 1/8. If I change these 1 into 8ths, this would be 4/8. And this would be 2/8. So the smallest one is 1/8, so that's less than 1/8. And 1/8 is less than 2/8, which they gave it to us as 1/4. And that is less than 4/8, which was 1/2. So there it is, least to greatest. Change your denominators to be the same so that you can easily compare the values. All right, let's move on. Number 4, changes in the weather can be predicted by changes in the barometric pressure. Over several weeks, Stephanie recorded the changes in barometric pressure seen on her barometer to compare to local weather forecasts. Her observations are recorded in the table below. Use rational numbers to record the indicated changes in the pressure in the second row of the table. Order the rational numbers from least to greatest. Again, least to greatest. Explain why the rational numbers you chose appropriately represent the given pressure changes. A rise is going to be a positive and a fall is going to be a negative. So 0.04. A fall of 0.21 is a negative 0.21. A rise of 0.2 is a positive 0.2. A fall of 0.03 would be a negative 0.03. A rise of 0.1 would be a positive 0.1. A fall, that's a negative 0.09. And another fall would be a negative 0.14. Okay, so there we are, and then we're going least to greatest. So the smallest number is the one that's the most negative. Let me see my negatives. I've got, let me change my color here. I have a negative here, and here, and here, and here. So those are the four I need to compare. The one that's the most negative, they're all in hundredths place, so that's nice for me. So negative 0.21 is my smallest. Negative 0.21 is less than, let's see, the next one would be 0.14, so negative 0.14 is smaller than negative 0.09, negative 0.09, and that's smaller than my last negative, a negative 0.03. And then I get to my positives, and in my positives I have 0.04. This one is in hundredths place, so I'm going to add a 0 so I get hundredths here, and I'm going to add a 0 so I get hundredths here. So those are my positives I'm comparing. 4 hundredths is smaller than 10 hundredths, so 0.1 would go here, and that is smaller than 20 hundredths, which would be 0.2, and that goes here. So there is least to greatest of those rational numbers. All right, next. The captain of a fishing vessel is standing on the deck at 23 feet above sea level. He holds a rope tied to his fishing net that is below him underwater at a depth of 38 feet. Draw a diagram using a number line and then use absolute value to compare the lengths of rope in and out of the water. Well, I'm going to make my number line a vertical number line to represent being above the water and below. Above the water line is going to be at 0. That would be sea level. And then we have a captain of a fishing vessel standing at 23 feet above. So I need 23 here. And I'm just going to count by tens. 10, 20, 30, 40. And 23 would be somewhere right in there. Okay, so that's at positive 23. And then I'd have a negative 10, negative 20, negative 30, negative 40. And negative, underwater means negative, so we're underwater at negative 38. Negative 38 is going to be really close to negative 40 down here. So this is a negative 38. And then if we use absolute values, we would say the absolute value of 23 is 23. So it's 23 feet of rope above the water line. And the absolute value of negative 38 is 38. Remember, absolute value is the distance. So we're talking about the distance from the water line, sea level, to the end of the rope. And so I can see that the rope that is underwater is more. There's more rope underwater than above. Okay, and then the last one for today. A recent television commercial asked viewers, do you have over $10,000 in credit card debt? What types of numbers are associated with the word debt? Well, I would say that debt would be negatives. Those are going to be negative numbers. And then write a number that represents the value from the television commercial. Well, the number associated would be a negative 10,000. So that would be the number associated with that debt of $10,000. Give one example of over $10,000 in credit card debt, and then write a rational number that represents your example. Well, my example would be if you had, let's say you had $15,000 in credit card debt. So $15,000 in credit card debt would be over $10,000. And then my rational number that I would use would be a negative because it's debt. So this is 15,000, negative 15,000. How do the debts compare, and how do the rational numbers that describe them compare? Well, if I have a debt of 10,000 from the commercial, and I used a debt of 15,000, 15,000 is more than 10,000, so I can say 15,000 is greater than 10,000. And then if I use the rational numbers that I used, that was debt meant negative, so I had a negative 10,000. And $15,000 in debt was a negative 15,000. Then I would say that negative 15,000 is less than negative 10,000. Okay, so there is the comparison, and you notice when I use a positive and a negative and I order them, the order changes. All right, that is lesson 13. I hope that helps. I'll see you again next time.